Solve the system by graphing y equals x squared minus 6x plus 5 and y equals x minus 1. Begin by graphing each equation, then estimate the point of intersection. The graphs appear to intersect at 1, 0 and 6, 5. Now check these points by substituting the coordinates into each of the original equations. First, check the point 1, 0 in equation 1. To do this, substitute 1 for x and 0 for y in y equals x squared minus 6x plus 5. 1 squared is 1 and negative 6 times 1 is negative 6. 1 minus 6 plus 5 is 0. Because 0 equals 0 is a true statement, 1, 0 is a solution of the equation y equals x squared minus 6x plus 5. Now check the point 1, 0 in equation 2 by substituting 1 for x and 0 for y in y equals x minus 1. 1 minus 1 is 0. Because 0 equals 0 is a true statement, 1, 0 is also a solution of the equation y equals x minus 1. So 1, 0 is a solution of the system. Next, you want to check the point 6, 5 in equation 1 by substituting 6 for x and 5 for y in y equals x squared minus 6x plus 5. 6 squared is 36, and negative 6 times 6 is negative 36. 36 minus 36 plus 5 is 5. Because 5 equals 5 is a true statement, 6, 5 is the solution of the equation y equals x squared minus 6x plus 5. Now check the point 6, 5 in equation 2 by substituting 6 for x and 5 for y in y equals x minus 1. 6 minus 1 is 5. Because 5 equals 5 is a true statement, 6, 5 is also a solution of the equation y equals x minus 1. So 6, 5 is also a solution to the system. So the solutions are 1, 0 and 6, 5. Solve the system by substitution. Y equals x squared minus 4x, and y equals negative 4. The equations are already solved for y. Begin by substituting negative 4 for y in y equals x squared minus 4x, giving you negative 4 equals x squared minus 4x. To solve for x, first add 4 to each side, giving you 0 equals x squared minus 4x plus 4. X squared minus 4x plus 4 factors as the quantity x minus 2 squared. By the zero product property, you can set each factor equal to 0. Because both factors are the same, you have 0 equals x minus 2. To solve 0 equals x minus 2 for x, add 2 to each side, leaving you with 2 equals x. You are given that y equals negative 4, so the solution is 2, negative 4. Solve the system by elimination. Y equals x squared plus 2x minus 5, and y equals 2x minus 1. Because the coefficients of the x terms are the same, you do not need to multiply either equation by a constant. Subtract y equals 2x minus 1 from y equals x squared plus 2x minus 5. This gives you 0 equals x squared minus 4. To solve 0 equals x squared minus 4 for x, first add 4 to each side, giving you 4 equals x squared. Then take the square root of each side, leaving you with positive or negative 2 equals x. Now substitute 2 and negative 2 for x in y equals 2x minus 1 and solve for y. First substitute 2 for x. 2 times 2 is 4, and 4 minus 1 is 3. So when x equals 2, y equals 3. Now substitute negative 2 for x. 2 times negative 2 is negative 4, and negative 4 minus 1 is negative 5. So when x equals negative 2, y equals negative 5. So the solutions are 2, 3, and negative 2, negative 5. Approximate the solution or solutions of this system to the nearest thousandth. Y equals x squared minus 2x minus 5, and y equals 2 to the power of x plus 1. Begin by sketching a graph of the system. You can see that the system has one solution between x equals negative 2 and x equals negative 1. Substitute 2 to the power of x plus 1 for y in y equals x squared minus 2x minus 5. Then rewrite the equation as 2 to the power of x minus x squared plus 2x plus 6 equals 0. Because you do not know how to solve this equation algebraically, let f of x equal 2 to the power of x minus x squared plus 2x plus 6. Then evaluate the function for x values between negative 2 and negative 1. The function values that are closest to 0 correspond to x values that best approximate the zeros of the function. You find that f of negative 1 and 8 tenths is approximately equal to negative 553 thousandths, and f of negative 1 and 7 tenths is approximately equal to 18 thousandths. Because f of negative 1 and 8 tenths is negative and f of negative 1 and 7 tenths is positive, the zero is between negative 1 and 8 tenths and negative 1 and 7 tenths. F of negative 1 and 7 tenths is closer to 0 than f of negative 1 and 8 tenths. So decrease your guess and evaluate f of negative 1 and 71 hundredths. F of negative 1 and 71 hundredths is approximately equal to negative 38 thousandths. Because f of negative 1 and 71 hundredths is negative and f of negative 1 and 7 tenths is positive, the zero is between negative 1 and 71 hundredths and negative 1 and 7 tenths. F of negative 1 and 7 tenths is closer to 0. So decrease your guess and evaluate f of negative 1 and 701 thousandths. F of negative 1 and 701 thousandths is approximately equal to 12 thousandths. The result is positive, so decrease your guess again. F of -1 and 702 thousandths is approximately equal to 7 thousandths. The result is still positive, so decrease your guess again. F of -1 and 703 thousandths is approximately equal to -1 thousandth. The result is negative, so you can stop here. Because f of -1 and 703 thousandths is closest to 0, x is approximately -1 and 703 thousandths. Now substitute x equals -1 and 703 thousandths into one of the original equations and solve for y. Substituting -1 and 703 thousandths for x in y equals x squared minus 2x minus 5, you get the quantity -1 and 703 thousandths squared minus 2 times -1 and 703 thousandths minus 5, which is approximately equal to 1 and 306 thousandths. So the solution of the system is about -1 and 703 thousandths, 1 and 306 thousandths. Solve the negative of the quantity 3 to the power of x plus 3 equals x squared minus x. You do not know how to solve this equation algebraically, so use each side of the equation to write the system y equals the negative of the quantity 3 to the power of x plus 3 and y equals x squared minus x. Use a graphing calculator to graph the system. Then use the intersect feature to find the coordinates of each point of intersection. One point of intersection occurs when x is approximately -1 and 23 hundredths and y is approximately 2 and 74 hundredths. The other point of intersection occurs when x is 1 and y is 0. So the points of intersection are about -1 and 23 hundredths, 2 and 74 hundredths, and 1, 0. And the solutions of the equation are x is approximately -1 and 23 hundredths and x equals 1.